The second half of 10.13b is about the interval of convergence. We talked yesterday about the radius of convergence, and this will help us decide what the exact interval is after we've found that radius. So a reminder that you have three options for convergence for power series. It could converge for just one value of x, it could converge for an interval centered at x equals a, or it could converge for all real numbers. What we're doing today will do nothing for those first and third conditions. So if it converges for one value of x, then you don't really have an interval of convergence, you just converge at that one value. If you have an interval that's centered at a, if you get a radius of convergence that's a positive number, then you have to check the endpoints, and that's what today's about. If it converges for all real numbers, then you're done. If your radius of convergence is infinite, you don't have to check the endpoints because they're infinite. So that's what today's going to be about. We're going to be using it to check the endpoints, really. That's all we're doing today. How do we find the interval of convergence? Well, we listen to Yoda, we use the ratio test, and then we have to test the endpoints because we have to beware of the dark side of the ratio test. The dark side of the ratio test is that if you get a limit of 1, the ratio test does not help you. The ratio test fails if you have a limit of 1. It doesn't even tell you whether it doesn't say that it diverges, it just says you've got to try a different test. Right. So for this first example, we're going to walk through the steps. The first step is do the ratio test. All right, so we're going to do that. Remember, the ratio test is the one that says we're going to do the limit of the n plus 1th term over the nth term, and we're going to find that has to be less than 1. So that's what our goal is as we do this. So it's going to be 8 to the n plus 1 over n plus 2, and then in the numerator we'd have x minus 2 to the n plus 1. Now we're going to multiply by the reciprocal so that we can divide. So our reciprocal would be n plus 1 over 8 to the n times x minus 2 to the n. And that limit has to be less than 1 in order for this thing to converge. We can do some combining of terms and simplifying a little bit. So we have 8 in the numerator, and we have x minus 2 in the numerator, and then we have n plus 1 over n plus 2. And this goes to 1 as n goes to infinity. Oops. I just realized I wrote an 8 instead of an infinity sign. You know what I meant. So then we have the absolute value of 8x minus 2 is less than 1. So now we're going to solve for x to get the interval. When we solve for x to get the interval, we're going to go from -1 to 1. We're going to add 16. And we're going to divide by 8. Now, this is where the new part is. We're going to check the endpoints. We're going to see what happens if x is equal to 15 over 8. We have to do one of our convergence tests for that, not the ratio test, because the ratio test would give us a ratio of 1. We don't want it. That doesn't tell us anything. Okay, so now we're going to look at that series. If x is equal to 15 over 8. Well, if x is equal to 15 over 8, this would be 8 to the n over n plus 1 times, well, 15 over 8 minus 16/8 would be -1/8 to the n. So if I write that a little bit differently, these both have an exponent, the same exponent, so it'd be 8 over 8, so it'd be -1 to the n. Now, as I'm trying to decide what series to use, I notice this is, what test to use, I notice this is an alternating series. So let's write out a few terms. If I plug in 0, I get positive 1. If I plug in 1, I get negative 1/2, positive 1/3, negative 1/4, etc. This is definitely going to converge. You could either say it converges by the alternating series test, or you could say it converges because it's the alternating harmonic. We know that that one converges. All right, so we checked that endpoint and we found that that endpoint converges. So now we're going to check the other endpoint, x equals 17/8. So then we do from 0 to infinity of 8 to the n for n plus 1, and now we put 17/8 in. 17/8 minus 2 would be positive 1/8. And so this series is not alternating. This series is going to be just 1 to the n over n plus 1. And so this series would be the harmonic series, 1/2, 1/3, etc. So this one diverges because it is harmonic. All right. Now we're going to go back to our interval and put the correct signs in. We just wrote less than signs, but we really should have included this endpoint. All of this work right here is to decide that we were going to include 15/8. You still have to show all of that work. You have to prove it, really. Why did you include 15/8? And that's what today's lesson is about. Today's lesson is just about deciding whether it's less than or equal to or just less than. All right, here's another example. I don't have the steps written on this one. So we're going to do the ratio test first. Oops. That goes in the denominator, obviously. Because I need to do the reciprocal. Just to be extra clear, the reason I didn't use this negative 1 to the n is because I was doing the absolute value, and so that was not going to do anything for me. Okay, so I have the limit as n goes to infinity of n plus 1 over n. I have 1/4 because I subtracted exponents to get 1/4, and then I subtracted exponents to get x plus 3. This part goes to 1 as n goes to infinity. So my rough interval, well, my radius is going to be, if I do x plus 3 is less than 1. Now I'm going to set up the interval, but it'll be rough because I don't know whether I include the endpoints yet. I'm going to multiply by 4. I'm going to subtract 3. So then I have to check the two endpoints. So I'm going to check x equals 7. And now I am going to pay attention to that negative 1 to the n. That's part of my series. So negative 7 plus 3 would be negative 4 to the n. So I just plugged negative 7 in for x here. And then I have negative 1 to the n times n times negative 1 to the n. So I really just have the series n equals 0 to infinity. I have the series n. Well, that's definitely going to diverge because of the nth term test. The nth term does not go to 0, so this is a divergence series. So then if I do the same thing for x equals 1, I suspect it will also diverge, because usually the only thing different is that one of them is alternating. But let's look at it. So if I plug in n equals 0 to infinity, I have negative 1 to the n times n over 4 to the n. If I plug in 1, I get 4 to the n. These two cancel. And so I do have an alternating series, but it still diverges because of the nth term test. The nth term does not go to 0. So this is true as written. I don't have to include either endpoint. Okay, that is how you find an interval of convergence. Because these problems were so long, I only included 2 examples. Good luck, have fun.